So now that we've talked about the structure and the dynamics and the patterns in the image TaskGang application, let's start zeroing in on the real stuff, the source code. And hopefully, because we've talked about these other elements that are more visual and more design focused and architecture focused, the code will make more sense when we look at the code. Let's start by taking a look at the taskgang.java file. And this file, as you can see, defines a framework for spawning and running this gang of friendly tasks that work together to concurrently process input from a generic list of elements. And you can see here that this particular class plays the role of the abstract class in the template method pattern. And not surprisingly, image TaskGang, which inherits from it, plays the role of the concrete class. And we'll see that as we go through the comments in the documentation. So let's take a look now at the taskgang.java class. So we're now in the image TaskGang command line version. This is the project you can find in my GitHub repository. Of course, I'll put a link to it in the links, the description box in the slides, in the video rather. And if you go in here under tasks, you can see there's a TaskGang file. So let's go take a look at the TaskGang. And as I said before, this is a framework for spawning and running a gang of tasks that concurrently process input from a generic list of elements of type E for one or more cycles. And that's what makes it interesting. You can have a gang of tasks working for one set of input, and then you get the next chunk of input, they can go and work on that. So it gives you this ability to have sort of work crews work together doing processing that's coherent and coordinated. So TaskGang is an abstract class that it's got some methods that must be filled in by subclasses, and it implements the runnable interface. So it's a run hook method. Now we give it a field called minput, which is the input list that's processed by a given cycle, and that list can be set by the setInput method. There's also an executor field that will basically execute runnable tasks in the appropriate thread pool. We'll see where the thread pool comes from in a moment. We keep track of which cycle we're currently at. And of course, we use an atomic long because this can be called concurrently. And here's a getter method that gets the list to use as input. It returns the list. And here's the setter method that sets the list to use as input. And it also returns it just for good measure. We have setters and getters for an executor. You can set the executor. You can also get the executor, and it will also return it, as well as, set executor does not return it, but get executor returns it. And then we have a method called increment cycle, which just increments the cycle by one. That can be used to keep track of what iteration you're on if you're doing a bunch of processing. We have a method to return the current cycle, which just gets the results of this atomic long. And now we've got our first of several abstract methods. These are the ones that must be defined by subclasses. So must be overridden by subclasses or by a subclass. So you can see that this method just returns the list, gets the next thing to work on. Now we have another method here called the initiate hook, and this is called back a little bit below to enable subclasses to perform any custom initializations they need to do before the tasks in the gang are spawned. We're not actually going to use that for this program, but it is useful for other use cases, so I left it in here. Here's the initiate TaskGang method. This is our second abstract method that must, of course, be overridden by subclasses, and this is what initiates the TaskGang. You'll see how that works when we look at the image TaskGang in our next walkthrough in the next part of the lesson. There's a method called advanced task to next cycle, which is a hook method that returns true as long as there are tasks that need to keep going. By default, it returns false, which means that the TaskGang starts out being a one-shot TaskGang, but if you don't want one-shot behavior, you can override this and keep returning true until you've processed all the input and all the different cycles. There's the third abstract method called await tasks done, and this can be used as an exit barrier that the calling thread that kind of kicks everything off will use to wait for the gang of tasks to exit, and this must be overridden by subclasses. There's a method called task done, which is called whenever a task is done, and this can be used in conjunction with either a one-shot or a cyclic barrier. Wait for all the other tasks to complete their current cycle, and it's past the index of the work that's done. It returns true if the wait was successful or actually, I'm sorry, it doesn't return anything. It just says, I'm done. Let's get rid of this return true thing. But it will throw this index out of bounds exception if the item has been removed at some point. That's just there as a sanity check. Now we have yet another fourth abstract method called process input, and this is really the starting point for doing the work in a background task. If all goes well, it returns true, otherwise it returns false, and that basically says don't keep going. This method, of course, must also be overridden by a subclass, and you can see it takes input data to work on in that background task. And then we've got a run method. This is the run method that's basically occurs because we implement runnable here. And this is the run hook method that's going to be called to kind of kick everything off. And what this does is it gets the next input chunk, makes that the input, and then it invokes the hook method to start up the gang of tasks. So that'll start all those tasks. They'll be running in this particular case in the background using an executor completion service instance with different types of thread pools. And then this method calls await tasks done, and that will wait for all the tasks to exit. And notice that this call will run in the calling thread. Whoever calls run, it'll run in that thread, but all the tasks that are running will run in a background in one of the thread pools that we'll see. And then the final method here is a factory method called make task, and it takes an index, which is the index into the list, and it goes ahead and it gets the item that's at that index location in the input list at this point, and it calls the process input hook method, which we looked at just a bit earlier. And as you can see, process input, we'll take a look at what process input will do here in a second. But process input basically is going to go ahead and process the input data, and then when it's done, it'll indicate that that task has finished. And so if you're waiting for all the tasks to be done, that gives you a hook to know that that one's finished. If something goes wrong, we basically throw an exception, or sorry, we return. What you'll notice here is that this is returning a runnable. And so it's going to be used, we're going to take the results of make task to execute it in the context of a Java thread pool. Another thing to note is that make task is both a factory method, because it makes something, it returns a runnable, and it's also part of the template method pattern because it's a single method that calls hook methods that can be overridden, including process input and task done. So that's basically the walkthrough of the TaskGang methods.